Hi everyone, and welcome to the, second to last talk in this afternoon session on the data science track in our PyCon Sweden 2021. And welcome Magnus. Magnus is a tech lead at Nexer with more than 15 years of programming experience. And Magnus will share with us about infrastructure as code for data science using Python. Welcome, Magnus, and the stage is yours here.
Thank you very much, Slavik. Really nice to be here presenting this session. Been attending PyCon now for some years, and it's really nice to be on this side as well, presenting a session. So very welcome to this session that is called Infrastructure as Code for Data Science using Python. So let's jump into the agenda. So I will start with just introducing myself a bit and the company I work for, Nexer. Then we'll dive into the evolution of data science in the cloud, how cloud has kind of progressed data science during the last couple of years here. And then we'll connect this to the topic of infrastructure as code, which is our main topic, of course. And we look at different type of infrastructure as code, because there is a couple of different types that you can present code or your infrastructure as code. And how does Python fit into all this? Because we're at PyCon now, so of course Python is our main objective here. And how do we tie this together with the MLOps kind of way of working, and how do we get the infrastructure into this topic as well? And we'll end with some key takeaways from working with infrastructure as code for data science. And in the end, we will have some time for questions as well. So let's start with a bit of background about me then. So I'm Magnus Perman, working for Nexer Group here in Sweden. I have a Master of Science in Computer Science from Lund. I am a Tomorrow pilot and tech lead in data science at the company I work for, Nexer, and I work with global clients within retail, industry, and media. I've been working with this field since 2004, working in projects within data warehouse, BI, that is business intelligence, and analytics for quite a long time. And I have 3 times Google Cloud professional certifications. And here's my email, if somebody wants to contact. So the company I work for, Nexer Group, we have our motto of promising future. And of course, a promising future for our clients and for our co-workers, and of course, for the society as a whole. We see tech as an enabler of a promising future. So there is a lot of capabilities in tech, and we want to connect that to the society. And we have a lot of social initiatives within the company as well. We are sponsoring schools in South Africa and so on. So there is a lot of connection to the society from our company as well. And how do we make this happen then? So we have 3 different areas of the company where we work with tech, basically. So we have everything from the strategy, where we work a lot with digital advice, analysis, and implementation. And then, of course, we have the technology side, which is our core. This is the heart of what we do, basically. We are staying ahead in the digital transformation and creating innovative technical solutions. So this is, of course, the core of Nexer, but we also have the communication. We actually have an embedded digital communication agency within Nexer. So we are really good at communicating around technology as well, because that's really important. If you can't communicate around the technology, and then of course nobody will understand it. So these 3 areas is where we focus within Nexer Group. And a bit of a facts around Nexer then. So we are 1,900 employees. We are, the background of Nexer was founded in Sweden, but now we are in 10 countries in total, and we have a revenue of 2 billion Swedish crowns. And it was previously called, the company was called Sigma IT in the beginning of this year. We changed name to Nexer. So if you are familiar with Sigma IT, that was our name before. And we are not publicly listed. We are privately owned by the Daniel Group. And if we look at that group of companies, then there are 8,000 employees in roughly and 16 countries and roughly 6.6 billion Swedish crowns of revenue. So thank you for listening into that. So we'll dive into the actual topic now. So infrastructure as code. Maybe 10 years ago, it looked like this. A guy setting up some infrastructure in racks in a data center somewhere basically setting up computing power and storing capacity. Today, this is how it looks. Most companies are working primarily in the cloud now. So you're buying the infrastructure from a cloud vendor like Azure or Google or AWS. So of course, this simplifies a lot. And if we look about how it looks, how data science has evolved through the cloud adoption, then I mean, data science is a lot about experimenting. So it's an experimental field of work. You are creating some models, some data feature engineering, and you're just trying out a lot of different things to try to get as good predictions as possible. And what cloud does for you is that, of course, this simplifies experimenting. You can have like a supercomputer at your fingertips in just a couple of clicks away. And you can spin up this huge monster VM with 100 CPUs and terabytes of RAM. I mean, in just a couple of clicks. So, of course, what the cloud does is that this simplifies a lot. I mean, in the old days, maybe you needed to order this from some operations department that gave you this server maybe a week later, and then it needed to be installed some software on it, and so on. So the lead times for actually performing data science and experimenting has really decreased during the last year here with the cloud adoption. And of course, what this does is that it empowers the data scientists a lot. Since you have all this capacity at your fingertips right now. But of course, with great power comes great responsibility as well. So if you have the possibility to do a lot of things, then there is a lot of things you need to think about as well. So you need to think about the cost, the security, if this is reproducible, a lot of things that basically come together with this great flexibility. And as well, if you're trying to do all this manually, trying to create infrastructure, then you will end up in like a death by clicks scenario. You will click around, and if you do this every time, spin up and spin down infrastructure, then it will be a lot of manual work basically for you. And it's maybe you don't really remember how you did it the last time and what type of configurations you used and so on. And as well, if you do this manually, then it will be basically key persons over time that will probably learn how to do this, and then they will become the go-to guys or girls to when you basically spin up infrastructure. So you will have this type of that knowledge is tied to a limited set of people then. So infrastructure as code comes to the rescue then. So I mean, infrastructure is critical in data science. We are in such a compute-heavy field of work, and of course, infrastructure is a critical success factor when working in data science. So of course, if we look at them trying to get this, trying instead of clicking around provisioning VMs, clusters, etc., trying to do this manually. Why can't we try to do it with code instead, trying to represent the infrastructure in code, basically, instead of doing this manually? And then infrastructure you will have a lot of positive effects by this. So infrastructure becomes cost effective. I mean, if you can represent the actual infrastructure in code, you can run this code how many times you want, basically, to build up and tear down the same infrastructure over and over again. So it's cost effective. since you don't need to spin up resources and have those hanging around either, because that costs money, of course, in the cloud environment. Everything that is up and running costs money. So you want to build up and only use the infrastructure when you're supposed to do, and then you tear it down again as quickly as possible. So the infrastructure becomes reproducible. You can run this how many times you want. You won't be dependent on key persons anymore, because you have it in code or in templates right now. So many people can reuse this code and work on it, and you won't lose the knowledge. You can automate the infrastructure, how you build it up and tear down as well. And you can even version control the infrastructure. So these files where you keep the infrastructure, these code files, you can version control. And you can even test these files, of course, before you deploy the infrastructure. And you will be drift resilient as well. So what does that mean? I mean, in an infrastructure, if you set this up manually, over time, the infrastructure will drift, it will change. Some people will add some more VMs, maybe add some bit of a memory, change some other configuration. And after some time, basically you have lost track of what different changes have been done to the infrastructure. But of course, if you keep this in code all the time, then it will be drift resilient, your infrastructure. You will keep track of the actual state of the infrastructure. So going from these Lego guys trying to build something manually here with the Lego bricks, we can think of infrastructure as code into this type of robot scenario, where we have a robot that we give some instructions. This is the infrastructure we want. And then the robot will build up the infrastructure based on those instructions. And of course, then the robot will do this exactly the same over and over again. The infrastructure will look the same how many times the robot is building this. And as well, the robot will take care of destroying the infrastructure once it's once you don't need it, and put the Lego bricks down into these boxes again. So there are a couple of different types of infrastructure as code. One is the imperative. It's called imperative. And here you give detailed instructions on exactly what to do in the infrastructure buildup. The other type of infrastructure as code is called declarative. And this is where you define the end state. So instead of having to keep track of all the different things you need to create the infrastructure, you just say, this is the infrastructure I want as an end state. And then the infrastructure as code tool will take care of getting your infrastructure to that defined end state. So of course the imperative here, it has a bit more of flexibility, since here you are basically giving it really detailed instructions down to the most detailed level, so it can be used for more complex configuration. But if we look at the declarative, then that is an easier to learn type of infrastructure as code, and you always end up in the same state. Since you are declaring the end state of the infrastructure, then it will always end up in this end state. While if we look at the imperative, that is basically you have a really detailed script scenario, and that of course depends on the start state of that when you were running those detailed instructions. Then you could end up in different end states of the infrastructure. So really useful to look at these different type of infrastructure as code. And I think the declarative is, of course, the one to go for here if you are just trying out and try to learn something, because it's really easy and fast to get up and running. So if we look at a couple of tools for infrastructure as code, and if we look at the declarative ones, then some of the most famous ones is one called HashiCorp Terraform. So here you are coding in something called HashiCorp configuration language. So that's the language that you need to learn then to code your infrastructure in this tool. And if we look at another tool, it's called Pulumi, and here you can code in your own language. So for example, I mean, now since we're on Python, then Python is our objective here, and that fits really good into our data science field as well, since most data scientists know Python. So here you can actually code in Python, so you are representing the infrastructure in Python, basically. And then what these tools do is that they will keep track of your current state, and then they will of infrastructure and compare it with your code, and then they will adopt the infrastructure to comply with your end state. Both of these are free, they are open source, and they work on any cloud. So they work on Azure, on AWS, and Google Cloud. And as I said, they are declarative type of tools. And we will look at some examples on these later. So if we look at the examples here for Terraform, it could look like this. Now I have a really basic one example, but here is the Terraform configuration file. So basically you're saying I want I want one VPC network, one virtual machine of type F1 micro, and then I would just want to connect that to the network, and I want to have a boot disk to that one as well. So you are declaring the end state, your wished state of infrastructure. And if you then run, maybe it's a bit hard to see here, it's very small, but if I run something called Terraform apply, it will connect to your infrastructure in the cloud, in Google Cloud in this example, and it will compare, okay, what does the infrastructure look like in this project that I have declared, and what is my wished end state. So it will compare the actual infrastructure with your declaration file here, and it will give you a way forward to get to the end state. So it will give you the suggestions that it will create a virtual machine, and you just have to accept that and press Y in this tool. Now I'm showing it manually here. Just press yes, and then it will take the infrastructure to that end state. And in the end, if I would just want to take it down again, then I will run the reverse, a command that will basically just destroy, take down the infrastructure that you created in your declaration file. If we look at another example, the Pulumi one, of course, this is what we want to look at now since we're on Python. And this is here you have the actual configuration file in Python code. So this is a really simple one. I'm just creating a storage object in Google Cloud. And here I'm placing a file called index.html as well in this bucket. And then I just export that one to make it available. And then I run a command called Pulumi up, which really works basically the same as in Terraform. It will change or it will check your current infrastructure and compare it with your wished end state, and then it will give you okay, so this is what I will do to perform to get you to that end state, and then you just have to press yes, and then it will go through and update your infrastructure. So these tools, they always have they are always checking your infrastructure in this cloud provider. They have a state file, and then they compare that state file with your wished end state. And then it will do the changes based on that. So if we look at the vendor specific, of course, this is a really hot topic, a really useful area. So the big cloud providers, they have created their own infrastructure as code tools as well. So in Google, we have something called Google Cloud Deployment Manager. In Amazon, we have the AWS CloudFormation, and in Microsoft, we have Azure Resource Manager. And these tools, you're declaring the infrastructure basically in JSON file or in YAML syntax. So if you're familiar with JSON and YAML, you would be quite easy to get up and running in these tools as well. And I mean, since so if you're only working in Google Cloud, for example, then yeah, you can use Google Cloud Deployment Manager a lot. But if you want to go through different type of clouds, if maybe you have environments in many different clouds, then Terraform or Pulumi is really good because they can actually connect to multiple clouds and do your updates on that. And we need to look at the other type of a tool, which is looking at the imperative as well. And a tool for that is Ansible. So that is more of a configuration type of management tool. So it's basically storing scripts. You're doing it as a procedural approach. It does not really store state, but it's open source as well. So here you can if you're really advanced and I mean you know exactly what to do and so on, then Ansible is a great tool for that. But it works on the imperative type of infrastructure as code. So how does this tie into MLOps if we look at infrastructure as code with the MLOps? So basically MLOps or machine learning ops is DevOps plus data plus model. So you're familiar, I guess, with the DevOps way of working. I mean, you are planning, creating, verifying, packaging code, and then you're releasing it, configuration, and monitoring the code through the ops stage here. But the new thing with MLOps is that you don't only have the code, you have the data as well, and the model connected to the data that needs to be somehow stored somewhere. So the data and the model comes into this kind of cycle here as well. And how does this tie into infrastructure as code? I mean, if you have an advanced DevOps or an MLOps cycle here, then you want to include the infrastructure in this as well. So of course, if you have this in code, then you can release your infrastructure and you can code your infrastructure as well. And that is really beneficial for setting up data and machine learning pipelines and do feature engineering on the data and so on. This is really good if you can get that into the code as well, to getting the infrastructure together with the actual code. You will benefit a lot if you have that in this cycle. So some key takeaways from this session then. So I mean, since data science is such an experimental field of work and it's so compute heavy, it's a compute heavy field, then if you can get infrastructure as code done in a good way, it will play a major role for repeatable results. That's something we want in data science. If you have a model that works really good, it's fast and it creates good results, then you want to be able to repeat that over and over again with the infrastructure connected to that. It will be cost effective. It's really easy to build up and tear down fast. So that's also something you want, of course. And you can reuse the code. You can share the code within your company for different type of similar work. You can do templates of infrastructure that you can reuse in different fields. And you can automate this, of course. So you are connecting this to the DevOps or MLOps cycle here. So you're actually automating the infrastructure. And in short, I mean, what you build is you build quality and effectiveness with the infrastructure as code. And infrastructure as code can now be done with Python, as we saw before. So, I mean, we have Python as a common language for most of us data scientists. So it really empowers us to be able to handle the infrastructure in a really good way now as well in code. So that turns us into the next picture here. So it's a promising future with Python for the infrastructure as code as well. And thank you very much for listening into this session. And do we have any questions?
Hi, Magnus. First of all, thanks a lot for an excellent overview of the tools we can use for infrastructure as code. Indeed, recently it's booming. It's been booming like hell due to the COVID situation.
Yep.
Yes, we have a couple of questions from the audience. I will pop them one by one. Mine's last. So Amira is asking if there is a rule of thumb for for when to use the Terraform or Pulumi libraries?
Okay, yeah. So I mean, Terraform has a really large user base, and it's a really good tool as well. What is good with Pulumi is that you don't need to learn a new programming language. So if you're already a programmer in Python and so on, I think you will get faster up and running using the Pulumi tool to basically represent your infrastructure in Python code. So it's really up to you if you want to learn a new tool like Terraform and learn this HashiCorp language, or if you want to continue with Python and actually use your Python code to represent the infrastructure.
All right, thanks. And Christine is asking, how do you ensure a constant setup between projects and use cases when the infrastructure as code is decentralized?
Okay, so how do you ensure constant setup between projects, use cases? Yeah, okay, so I mean, trying to decentralize the infrastructure as code. Usually, if I'm working I mean, if we talk about projects in the cloud type of environments, then usually you are working a couple of different teams within the same projects, and I think sharing the infrastructure and sharing the templates through that will give you great benefits. But of course, it's a collaboration efforts, and the more teams you have using the same infrastructure, the more you need to collaborate on the infrastructure as code as well. But I think the power of being able to share and not starting over and over again with the infrastructure will give you a lot of benefits.
All right, thank you. And I've also got a question. How much should a data scientist, or I presume, say, a junior level data scientist, be concerned about all this, about the infrastructure and the code and all the technical details?
Yeah, I think general answer is not being perhaps concerned, but I mean, it empowers you a lot. And I mean, if you come to a big company that has a cloud environment, then of course you won't be on your own trying to set up infrastructure. There will be like teams or specialized people that knows a lot around the infrastructure. So you're not left on your own. But what you can take away is that if you want to learn how to represent the infrastructure as code, it will, you will get a lot of empowerment from this, and you will get up and running and do a lot of experimenting on your own.
You'll be able to get another job, right? Different field.
Yeah, basically.
All right.
Yeah.
Thanks a lot, Magnus. I think the audience appreciated it, and we liked it a lot. And hope to see you at PyCon Sweden 2022.
Yeah.
With that,
absolutely. Thanks a lot as well, and thanks for everybody that listened in, and really good questions. This was really fun.
Yeah. Thanks for watching. Bye bye.
Thanks. Bye.